We have three very different topics today. We have Yuvraj Kadale, Savio Minifer, and Shivam Sharma from the XRS Fellowship Program. And they're going to share their open source projects that they did in collaboration with Equal Entry and XR Access's Prototype for the People. For those of you on YouTube, please type any questions you have for our presenters into the chat. We'll be asking those at the end of today's presentation, and we'll be starting the presentation today with all three speakers giving you an introduction to the work that they did. And so with that being said, I'm going to now hand it over to Yuvraj. Yuvraj, take it away.
So I'm Yuvraj Kadale from India. I am here as an XROS fellow, and today I will be sharing my work with you all. During my XROS fellowship journey, I have created a vision accessibility toolkit, and let's see what it is. So I will be giving brief of what VRC is. VRC stands for a virtual reality check. It refers to some set of guidelines which are defined by Meta to ensure that virtual reality applications meet certain standards and requirements for the performance of functionality and user experience. So there are these virtuality checks which are defined. So coming to the VRC accessibility feature 5, which I have worked on, it states that the application should enable people to edit their display settings, such as brightness and contrast, to enhance their visual needs and comfort. So this is the demonstration of the project which I have created. This is the Vision Accessibility Toolkit, and it has been implemented on the first-hand project, which is open sourced by Meta. So as you can see, user is able to change its contrast as soon as the contrast slider is getting changed. In the real time, we are able to see the difference in the visual display of the application. One can observe here when we change the saturation and reduce it to the minimum value, we see it in the black and white space. This feature is very helpful for the developers to test it if their application is dependent on any color or not. Similarly, there are some other features like temperature, tint, and hue shift. So hue shift is one of my favorite as it enables the user to completely change the colors, and it is very helpful for the user who have some kind of color blindness. So moving forward, how this functionality will actually help the users. So how is it creating the difference? One can see here, this is how the user application was looking when there is the normal contrast settings. But as soon as the user is changing it and enhancing the contrast, the text are more visible. The UI has been improved. There is less eye strain, and it allows the user to customize their experience. Next, moving to the saturation feature, the huge difference it creates for the user who are having this achromatopsia. So this is the condition where someone is partially or have total absence of color vision. So people with complete achromatopsia cannot perceive any colors. They can see only black and white shades and some shades of gray. So setting the saturation value to minimum, it changes the complete user experience into black and white, which helps user to get interaction completely with the application. So this feature can be also helpful for the developers to test their applications in the absence of color and actually verify whether the application is dependent on any sort of color or not. So as mentioned before, the hue shift feature, this feature helps the user to change the color and remove a particular color completely. So there are different types of color blindness: protanopia, deuteranopia, and retinopia. So protanopia stands for the color blindness in which the user have difficulty in seeing the red color. So by shifting the hue shift, one can see we have a red color here, and as soon as I shift the hue shift, the red color completely disappears. Similarly, deuteranopia is the one in which user has difficulty in perceiving the green colors, and tritanopia in which user cannot see blue colors. So this U-shape feature is very helpful for people with color blindness, and they can completely change their vision and get make that application more accessible. There are more to add on features which I have added, like temperature and tint. So one can change the temperature and get it more interactive application and feel it like they are how they are feeling in the current world. So one can try out this demo uh, on their Oculus. So I have dropped a drive link on the chat box. The link has how one can download the source code and actually experience that on the Oculus. On the same link, you can give me feedback on the mail ID. I have posted that on the doc. So here are few of the testimonials which I have received from the users which have actually tried my application. So we have this Sangeeta. She said that I'm truly impressed with the great work done to enhance inclusivity for the visual impaired. Now we can all share the same experience, creating a more inclusive world. Looking forward to even more exciting developments in the future. Then we have Kavish Imran, who said the app is really cool and interesting for the first time users. Now, with the options to visual controls, the color seems more vibrant and comforting. The color panel to the select a desired color pattern is really helpful for someone like me with red green color blindness, as now I am able to distinguish between objects of this color, which was difficult earlier. Then we have the feedback from Suvarna Maji. She says that the option in the visual settings tab were pretty handy. By adjusting a few settings, I was able to custom enhance the view and my optical experience. Last but not the least, we have Hemant Nagasai who said that really amazed by the VR experience. Now, even more amazing is the UI settings available for adjusting saturation, contrast, and hue, which change the entire attire of the visuals. This kind of customizations could make the user experience more smooth and pleasant, and I really appreciate the amount of hard work went in creating it. So, thank you for the feedback from all the users. In future, there are some future works which can be done to enhance this toolkit. One is the distance grabbing. Uh, how that means that in an application, if there is an object placed at a particular distance, a user with a low vision will have difficulty to see or perceive the object. So the user should have the capability to change the size of that object at any distance. And also, if the distance is so much large, the user should have an options to grab it from a distance and make it close to the user and actually analyze the object or perceive the object. So yeah, that's it. Thank you. That was all from my side. So I'm Yuraj Karale, an extras fellow from India. With this, I'm open for question and answers.
Good. Well, I will say, I just want to say that I love this project. To really want to emphasize that you have an easy way to implement this in your project from following all the step-by-step instructions that have been written here. So I think this is really a great place. And, you know, as shown here, the VRC item for implementing the accessibility checks, that's one of the things we were hoping with this work to assist Meta and Unity with, is a real step-by-step way to do it. So, I mean, I guess I'll just give you a quick question, Yuvraj. What did you find the most interesting part of like doing this work? Since you've been working on this fellowship for multiple months. What was the most interesting experience for you?
Yeah. So the very best experience which I had was having this first experience on VR. So I was completely new to the virtual reality world and how the things work. So being from a completely new background and moving to a new space, it was very exciting. And uh, thanks to Thomas Equal Entry and XR Access for providing me the hardware and actually helping me to experience that how VR looks like, how the virtual world is, and what are the actual limitations, current limitations, what users are facing, and how it can be made more accessible. So solving a real-time problem was very exciting for me, And as soon as the XR OS fellowship was ongoing, the challenges which I was facing and the solution which I was getting on the way path, uh, like it was the journey was so good that as soon as we were moving close to the destination, it was feeling more excited. And as the outcome of the project was coming, and I was getting the feedback from the user, interacting with the user, getting the feedback what I have developed and how it is actually helping or not. That was very exciting for me. So I would like to thank everyone for giving me this opportunity, and also so much thanks for giving me a chance to present my work. Yeah, thanks a lot.
Great. Thanks you. And everyone, you can follow up. There's an article on Equal Entry website with all the details of following these steps, and Yuvraj's contact information is available as well. And I think we're all excited to see what else can happen with this. There's one more question here. I will just ask you one more. With your future proposed work, are you considering how you can adapt the viewing experience for those requiring prescriptive lenses? So that currently requires an external add-on solution in some headsets. Maybe, I guess, for people wearing glasses or prescriptive lenses.
Yeah. So like this was in the field of VR. There are some other headsets available which helps the user to have the perspective lenses, and on top of that, the glasses can be worn. Uh, Alternatively, for the specific headset Oculus, in the future work, focal length can be added. So whatever perspective lenses the user is having, they have a particular focal length at what distance they can see. So developer can give an option to the user to change their focal length and adjust it as per their requirement. Once the focal length is changed, the user need not wear the glasses, and the VR itself will be able to display it on the eyes retina clearly. So that can be done on the future work. And alternatively, if we move from virtual reality to mixed reality, the user cannot need not wear any perspective glasses, or sorry, I mean the user can wear the perspective glasses on top of their headset. So it will be both the glasses, and they can actually interact with the world. Yeah.
Great. All right. Well, thank you so much, and thank you for your excellent work. And I look forward to see what other developers build on top of it. And with that, I'd like to now bring up our next speaker. So we'll be transitioning now to Savio for a completely new topic on making accessible solutions in VR. Take it away, Savio.
Hello, everyone. Thank you for coming today. With this presentation, I would like to share with you what I learned during this fellowship that I completed with XR Access, during which I created a caption system for virtual reality in Unity. So you're all probably aware of captions or subtitles. They are both similar. Subtitles are often for translating dialogue in movies and TV shows, but captions often focus on ensuring that dialogue and sound effects and music are accessible to people who are deaf or hard of hearing. When it comes to 2D media like television, captions and subtitles are commonplace. We could call this kind of subtitles 2D subtitles. And this is because they're meant for flat screens. 2D captions are relatively straightforward when it comes to implementation. Since the viewer is always looking at the screen, like a single point in space, captions can be placed at the bottom or the top of the screen. And moreover, 2D captions have been around for decades, which means that there are a lot of established guidelines and best practices when it comes to implementing 2D captions. Aside from TV and movies, 2D captions are also common in video games and other interactive media that is meant to be consumed on a flat screen. Now let's talk about captions in VR. When it comes to VR, captions are also important to ensure that experiences are accessible to people. But unfortunately, captions in VR are not that widespread. And this is because captions in VR are more challenging to implement than in 2D. There are a number of reasons for this. First, Users in VR are not always looking at a single point in space. They have the freedom to look around, and they can look behind you, and like they can literally look anywhere in the 360 degree of freedom that they have. So where do you put the captions? There's no easy way to answer this. This is the problem of positioning captions in VR. There's also scenarios to think about, like what if there's a speaker behind you, and what if there are multiple speakers? The problem is not that there's not a solution to this. There are plenty of solutions to the problem of positioning captions, but there is no single solution that's guaranteed to work everywhere. Let's have a look at a few examples of how other developers have solved this problem of positioning captions. This is a video from the popular game Half-Life Alyx. And here you can see that when the user is looking around, the captions follow their head wherever they go. And this is quite a simple solution, and these are called head-locked captions. Now let's look at another example. This is from a game called Vacation Simulator. And here the caption initially appears above the speaker on top of their head. But if you look away, then the captions follow your vision. So it's kind of a hybrid of normal captions versus like head-lock captions like we previously saw. Now, the two examples that we saw here illustrate two different ways to approach the problem of positioning captions. However, each solution has their own drawbacks. For example, in the video that you're seeing here, you can see that the captions move with your head. There's a lot of motion, and this might cause problems for people who have motion sickness. And in the previous example with the headlock captions, the problem is that captions always appear in the bottom half of your display, so you have to always look down. So it will be difficult to focus on what you're looking at. Now, the effectiveness of a positioning method often depends on the context of the VR app that you're developing. So you really have to think about what kind of positioning method works best for your captions. Now, let's take a look at a different problem. That's the problem of the developing captions. So VR captions also pose a number of development challenges. VR developers often have to start from scratch when implementing captions, and they have to identify what kind of captions work best for their app. As we saw before, you cannot just place some text on the 2D screen. You have to actually program how the captions appear in 3D and then move to accommodate other things. There's also a different problem. But before that, let's take a look at one of the virtual reality texts. So Yuvraj already talked about the VRCs. This is a different VRC from Meta, which is a recommendation for apps that are published on Meta's App Store. And they say that applications should be playable in its entirety without the use of audio by providing subtitle options or like for dialogue and sound effects. Now, Meta gives this recommendation, but unfortunately, they don't give any example code or resources to developers to easily implement captions. And there's also a lack of existing resources from third-party, from both first-party and third-party developers. Now, that was the problem of the development of captions. Now, let's take a look at a different problem. That's the problem of customization. We saw that different positioning methods work differently for different apps, but we also have to think that each user has different needs when it comes to captions. The font size, for example, how a caption appears, doesn't necessarily have to be the same for everybody. So people need to be able to adjust exactly how captions appear in the app. So the font appearance, like the font size, color, outline, then some people might also need a background for readability. And if somebody has motion sickness, they need an option to reduce the number of animations and captions moving around too much. And finally, we also need to think about different languages. So some languages like Arabic, for example, have right to left text, which means that the normal way of rendering text in Unity probably doesn't work in that case. So there's a number of customization aspects that need to be, we need to think about when developing captions. So during the fellowship that I did at XR Access, I worked on Chirp captions. Chirp is the name, it's just a random name we came up with, but it's a package for Unity that lets developers easily add caption support to their VR apps. Chirp aims to be an example of how captions can be implemented by providing developers with actual code and reusable components that they can use in their own apps. And most importantly, Chirp is open source so that anyone can see how it works and use the code in their own projects. Let's have a look at an example of how Chirp works. So here you can see that I am launching a demo app that I created using Chirp. And this is just a simple app where there's a number of characters speaking and captions appear corresponding to their dialogue. So here you can see that there are 3 different animals and they all have different voice lines. And when each one speaks, the caption appears at the bottom half of your display. Now, this is quite similar to the example that you saw previously with Half-Life Alyx, in that these are headlock captions. They follow your head wherever you look. Here you can see that there are little arrows that point to where the speaker is. So it's a way of determining who is actually speaking based on the captions. And you can also see this panel with a lot of settings. This is a pretty complicated panel at first, but this is just a demo just to show you what Chirp is capable of. So you can see that you can change a lot of the aspects of the text, like the font, the color, the font color, the background color, and even more options. There's also the option of like, how quickly does the caption follow your head? You can make it slow, or you can make it as fast. Making it fast might mean a lot more motion sickness, so maybe a slower setting works better for you. That was a quick demo of Chirp captions in action. And let's talk a bit about the features of Chirp. Importantly, that Chirp is a Unity package that anybody can download and integrate into their own Unity projects. So it's quite easy to integrate Chirp into your own projects. Chirp also supports multiple positioning modes. At the moment, it only supports headlock, but there's the possibility to add on different modules to it. So each module builds on the framework, the base framework of Chirp. So it's quite easy to add a new positioning mode to Chirp. Chirp has a lot of customization options, like you saw before. And Chirp has support for scripted and real-time captions. So scripted captions mean like you already have the caption text. So for something like a cutscene in a game, for example, you already know what they're going to say. So you can pass on the captions as text. With real-time captions, you can use an external voice recognition software to actually transcribe the captions and then pass it on to Chirp. Chirp is also versatile and extendable so that any developer can look at the code and add any features that they want. And Chirp is released under the MIT license, which is a really permissive license, which lets you do whatever you want with the code, and you can also publish it as part of your closed source apps. Now, I'll walk you through the steps of integrating Chirp in your Unity project. It's just a quick overview, not covering all the steps here, but just to give you an idea. So Chirp can be downloaded as a package from GitHub. You can just paste the GitHub link into Unity and it will automatically install it. And then Chirp comes with a handy prefab that you can add to your main scene. And this adds the functionality of Chirp. Then you can add a caption source script or a component to whatever object that you want to have captions. So if there's a speaker with a dialogue, then you can add a caption source component to them. And finally, you can call some functions on that caption source. So this is a simple example of a function where you can show this text for 3 seconds. Now, when it comes to the future work of Chirp, Chirp is still a work in progress. One of the main goals of Chirp is to make code and examples related to VR captions more widely available. So it's an open source project where the community can actually contribute to making Chirp better. So, and it's also meant to persuade platform owners like Meta to provide better documentation examples. So if there's more interest in VR accessibility features like captions, then this can persuade owners like Meta to up their game and make more resources available. Chirp was also a lot of learning for me. It was a great opportunity for me to learn about accessibility in VR. I feel like accessibility features for VR do not get the attention that they deserve, and more resources need to be allocated to them. This was a great opportunity to learn about that. Then there's also the open source aspect. This was probably the first open source project that I actually contributed to. I've used a lot of projects like Blender and a lot of software that is open source, but never actually got the chance to contribute back. So this was a great opportunity for that. Now, also another point to note is that there are a lot of existing games out there that have caption implementations for VR, but they're all closed source, but so that nobody can look into how they work and use them in their own apps. So for accessibility, open source is definitely the way forward. There's also a need for best practices and guidelines. Now, groups like the W3C Immersive Captions group are doing a lot of great work in this regard in terms of coming up with standards for VR captions. And this fellowship was also a chance for me to actually participate with the W3C group meetings and give my inputs on that and be part of that community. And talking about community, I think community is a really important aspect when it comes to accessibility and creating sustainable apps for accessibility. It's really important to build up that community and make sure that the people involved are actually really motivated to work on these problems, either because they suffer, like they have these problems, face these problems themselves, or because they want to use their skill to solve problems in accessibility. Yeah, that was my presentation. Thank you everyone for watching. And if you have any questions, please feel free to ask them in the chat.
Excellent. Thank you so much, Savio. And yeah, thanks for really illustrating and making the point on the open source nature of this work. I think that's really important. And I agree, for accessibility, we want to make this as easy as possible. So that was a really cool part of working with XR/OS, with this whole idea that everything that you all have built is available for people to take and customize, and the license you mentioned. All right, we have a few questions. Let's take the question first from Claudia. Hello, do you know if there's been any work on possibilities of creating captions for those that are deaf and blind using haptics or Braille, perhaps?
Haptics and Braille. Yeah, during the short time that I spent on this project, I did not come across any such projects. But it's definitely interesting because haptics is a different media. Like it's not this. So captions here is just a visual thing. It's just something that you see on your headset. But then being able to actually physically interact with text in a way is an interesting problem. And I haven't thought a lot about that, to be honest. So I cannot really give you an answer for that. But it's definitely an interesting subject, I think.
I agree. Interesting question.
Yeah.
Next, with chirp captioning, how can you make the distinction between what or who is talking at any time, especially if more than one character is speaking at the same time?
Yeah, that's a good question. So when it comes to captioning for VR, speaker identification is a really important aspect. There's multiple ways to approach this problem. So in the headlocked captions example that you saw before, let me see if I can quickly, or maybe you can also just have a look at the Half-Life Alyx example. You can see that each caption has a name preceding it. So that shows you who is speaking. That's quite a simple solution that's also often used in 2D captions that can also be used in 3D or VR. So in the example that I showed you, the demo, you probably noticed these little arrows which point to the speaker who is speaking. That's a different solution that also lets you know in like a spatial way, like who is speaking. So you can like turn your head towards that direction if you want to see that speaker. There's probably also different ways to do it. yeah, like maybe I'll have a look at the next example, and here, oh, yeah, here you can see that the captions have a little icon next to them. It shows you a little picture of who is speaking. So it makes a lot of sense in a game like this, where you probably are already quite familiarized with the characters. So a little icon is all that's necessary instead of a name or, yeah. But here you can also see those little arrows. So there's multiple ways of approaching this, and it also depends on the positioning mode that you're designing.
And let's just read a comment too from chat from Dylan Fox from XR Access. Going back to the comment on the Braille display, we need to ensure that the text input from the captions could go to a Braille display or something similar. Depends on how that text is produced and whether that output can be tapped into, I think. So yeah, maybe just some other thinking on if you make the text stream implemented in the application, can you make it available to like another application or like a hardware device to get access to it? Well, I want to say thank you so much, Savio, for your presentation. And again, as said with the previous, feel free to reach out to Savio for his work. And we are posting, a full article on the Equality website with the instructions on installing and using chirp captions. So you can actually try implementing chirp captions on an existing application and learn how you could put it in your own application. And that, now I'll go to our last presenter, Shivam. We will have another totally different presentation, and Shivam, take it away.
Hello everyone. So I think everyone is enjoying our session today, and so today is my last presentation, and my topic is locomotion in VR for people with disability. So I work as a XR developer in a research facility in India. I'm also the co-founder of an XR-based startup, 6DF Solutions, and under the XR OS fellowship with XR Access and Equalentry, I worked on Meta's VRC Quest 8. So that specifically focuses on multiple locomotion styles in VR application. So XR, that is extended reality, has great potential and it can play a significant role in the accessibility space. By leveraging the power of augmented reality, virtual reality, and mixed reality, we can create an exclusive and enhanced environment that can improve the quality of people with disability. So for this VRC, we are focusing on virtual reality and how it can play a crucial role with its immersive and interactive nature, and how it can open new possibilities for accessibility, empowerment, and improve quality of life for individuals with diverse abilities. So virtual reality has great potential in creating accessible solutions. By leveraging this technology, developers and designers can address mobility challenges, we can empower the users, and we can offer inclusive experiences. So locomotion, that was my topic. Basically, it refers to the base in which users can move around in a virtual environment. So the popular use cases of locomotion are teleportation, smooth locomotion, and room scale movement. So let's discuss what is teleportation. Suppose these are point A and point B, and you want to move between them. So using teleportation, we can directly move to point A to point B. If this is a point and teleport method, and it can be easily implemented. Next is smooth locomotion. In this, if we are moving from point A to point B, so we are moving smoothly and we are moving continuously like this. So this is another method of locomotion. The last is room scale method. In the last method, in this we have to physically move. Suppose we are moving from point A to point B, so we are physically moving in the real space, in our physical world, and that is working in the virtual environment. In teleportation and smooth locomotion, we are not moving in the real world. We are only moving in the virtual world. So these are the three basic locomotion techniques used in virtual reality. So by harnessing the power of this technology, we can create an inclusive space where individuals with mobility challenges can overcome barriers and they can participate fully in various aspects of life. So there are multiple advantages of VR locomotion. So we'll discuss few of them. First is remote work and collaboration. So VR collaboration tools, they can help people with disabilities to work remotely and participate in virtual meeting conferences around the world without the need of traveling to that space. So this reduces the need for physical travel and provide equal access to professional opportunities. So we are basically creating an equal ground for everyone with the help of virtual reality. Next is physical rehabilitation. So often in physical rehabilitation, we have to do mundane exercises daily, and we have a lack of motivation. With the help of VR-based gaming techniques, physical therapy exercises, we can create a motivational environment and that can engage in rehabilitation activities in a fun and immersive manner. So they can be customized exercises that can cater to individual needs and abilities. Next is interactive accessibility training. So VR can not only be useful for people with disability, it can also be useful for businesses and employees and service providers to better understand the need of people with mobility disability. So they can understand what are their requirements and how it is to, work with them, how they can create a better inclusive spaces for them. So with the virtual reality, we can create an interactive accessibility training module for them also. Another point is accessibility, tourism, and virtual travel. So our world contains various monuments, beautiful scenarios. So why should people with mobility disabilities restrict them from traveling to that places? Using virtual reality, they can visit these places and they can, they can foster a sense of exploration and cultural enrichment right at their place, right at their comfort of drawing room or living room. With the help of virtual reality, they can visit any monument, any place in the world, and maybe they can visit outer space on the moon and travel the solar system. So virtual reality can have endless possibilities. Next is obviously gaming entertainment. So as Ravi also mentioned, in gaming, virtual reality can be a revolution. And with the help of virtual reality locomotion, so player can move anywhere. Because they can fly, they can teleport. Multiple locomotion techniques can be implemented for them, and they don't have any barriers like they have in real world. So they can create a inclusive, accessible virtual world where they can play with their friends and they can, have achievements, participation, and they can create an immersive gaming experience. All this can be happen with the virtual reality. Next is they can virtually attend events and gatherings. So if they have any social event, concerts, family gathering, so using virtual reality, they can move around the event, they can experience that, and they can have a 360 immersive view. So it will be like completely they are experiencing that only, they are living there only, and living in the moment at the exact point, and they can, be there with their family and friends. And the last is quite important, emergency preparedness. So using virtual reality, we can prepare different evacuation routes. We can help them train with locomotion techniques, and they can understand the accessible emergency routes. So this can be quite useful during a disaster, and they can prepare themselves also, and they can help experts also like how to help them during the disaster. So these are some of the advantages of VR locomotion. So for this VRC, as I said, my VRC was MetaQuest VRC 8. So it focused on multiple locomotion styles, and this includement is not limited to teleportation, free locomotion, that is direct locomotion, and snap learning. So for this, we created a project, open source project that is available on GitHub, and it link can be shared after the session. And we will be always also posting a link for our implementation of VRC 8 on the Equal Entry website in short time. And these are some of the minimum requirements that you'll be needing to implement the project. So let's have a quick demo how it works. So in this project, we'll be focusing on free locomotion, snap turning, and teleportation. So these are the three locomotion styles that we have implemented in this project. So we'll start with snap turning first. So snap turning basically turning around left or right without rotating your head in real space. So using just the flick of a button of your controller, you can move left and right. Next is direct motion. So by pointing the direction and using your thumbstick, you can directly move from point A to point B. In this, you can notice you are moving continuously in the direction you are facing. And the last one is teleportation. So in this, you can just point to a specific teleport anchor and you can directly teleport to that point. So in this example, we are pointing towards the teleportation anchor, as you can see in the video, and we are getting teleported to that point. So this is how we can implement three locomotion styles in the virtual reality. And because this is an open source project, it can be implemented in any game. And you can have you can download it via our GitHub project. So it's quite easy to implement also. And you can see our article also after that. And we have all the steps listed there, how to implement that. So what will be the future scope of this project? So we have implemented the basic MetaQuest VRC 8 criteria, but how we can improve? So I would like to motivate everyone seeing this video, how you can extend this locomotion technique. And personally, I will also be working on this future scope techniques. So first is voice command locomotion. So imagine right now you are using a controller, but what if you don't want to, or you can't use the controller, or you can't hold the controller? So using voice command, you can create a completely controller-free experience. So suppose you're in a game and you want to move, so you can just use your voice command, like you can say, move 50 meters ahead, turn right, turn left. So you don't have to hold the controllers. You can just directly use your voice as your command, and it can move in the game. The next is gaze-based locomotion. So in this, you can see at a specific point in a game for X amount of time, and you'll be teleported or directly moved to that point. Suppose I have to move 180 degree, and I'll just say turn, and after that I'll just have to move 50 meters ahead. So or a specific point or a safe point. I'll just look at that, and there will be a loading buzzer, and after that is completed for say 5 seconds of time, I'll be directly teleported to that point. So in this, you don't have to even speak also. You just have to look at that point and you'll be teleported or moved to that point. This is also interesting locomotion style. Now is turning vignette for motion sickness. So what we notice is while we are teleporting from point A to point B, in virtual reality we are moving, but in real world we are not moving. So this causes an effect of nausea, motion sickness. So how we can reduce that? It provided tunneling effect. Like before teleporting, you will just select the point, and after teleporting, so the in between time there will be a tunnel produced that will be blocking all the external view, so you don't have motion sickness. So you can also implement this in your locomotion style, and it will help to reduce the motion sickness part. So this is also based on the observation of different users, and we should all work towards this, and we can implement these techniques and make a accessible gaming experience or virtual reality experience if we follow all the techniques listed here. Okay. Thank you, everyone. If you have any feedback or suggestions, this is my email ID. Thank you so much.
All right. Thank you so much. And yes, thank you. This is probably the teleportation locomotion topic is, one of the ones that feels very unique to VR compared to the contrast and to captions, which we've needed to do in other platforms. With the teleportation and locomotion, it brings up a lot of other types of disabilities like vestibular disorders. And, unfortunately for a lot of people that I've spoken to that use VR, they get motion sickness or they have problems with this implementation. So I do think it's a good example of the idea that a lot of times implementing something that will help people with disabilities benefits every user, and the idea of like not making people have to move a certain way in VR is very similar to not forcing people to, have to do another type of action. So let's take first question, or this is a comment actually, but I'd like you to respond to this. Would love to see this expanded for wheelchair users who could explore the metaverse either without a wheelchair or using a wheelchair with smooth locomotion, which would require flat surfaces or ramps. An idea, but what do you think of that?
Sure. So the goal of virtual reality can be to create a completely virtual environment in which the user can be anyone, or contrast to that, it can be an equal realistic environment that the user can identify with. If your user wants to be on wheelchair in that experience, we can create a simulator for that, so that the real world and virtual world matches the identity of the user. So we can, have a simulator. So I worked on a driving simulator in which we have the complete accelerator, brake, and steering wheel. Similarly, we can create a virtual wheelchair simulator for virtual reality. So this is quite beneficial of virtual reality, that you can be anyone or anything. So as I mentioned, you can be like completely different from your real world persona, or you can be exactly the same persona. Like you can create your own room in virtual reality. So now there are technologies also that you can just scan your phone and you can scan your room, and it will create a 3D model or 3D environment of your room. So definitely, if you want to have a real realistic experience in VR, so you can create a simulator for that, and you can experience the same world that you're experiencing with the help of that simulator.
Yeah, I think I just love that idea that in VR there's really no limit. So what if you were like, I'm going to re-render the environment to have a ramp or not have a ramp? Yeah, the fact that you can do all of that in VR, it's really cool. Here's another comment, and also something for you to comment on. So this is around probably like a social VR example, but would love to see a way of being able to locate a specific user within a crowded VR environment. Like think about like a shared social environment. What do you think about finding a user inside of a social VR?
Definitely, I think there are already some of the applications that are already working on social VR. But if you want to create an inclusive social VR, we can do that also, where people can share their experiences, have support groups. So we can definitely have that application also, and it can connect up users, different users with various disabilities from around the world in a common space. So I think during our fellowship experiences with XR Access and Equal Entry, we collaborated in the virtual space, and it was like quite interesting. Like we were sitting in different countries, but still in the virtual reality, we were like sitting in a common conference room, and we were presenting and having fun. So virtual reality can bring any type of group in a single room, and it's quite. I think everyone should experience that meeting or a conference, and they'll just see how close can we, despite sitting in different parts of the world. So obviously we can have different social groups or applications for different type of users in virtual reality.
All right, and then last question before we wrap up today. Could voice control potentially be used to locate specific objects or users? And I'll just add on to that question you mentioned that feature planning was voice control. Did you have any ideas of like how you thought the voice control should work?
Sure. So, voice control is not just a single use case. It has basically diverse use cases. So, what you are doing with controller should you should be able to do it with your voice. So, to talk on the first question, like we use distance grabbing. So, what we do in distance grabbing is we point towards a specific object in the game, and we can float it towards our hand, or we can grab it without actually going towards that object. So using voice control, we can do that. We can say if we can have a tag, we can have different tags to different objects in the game. And suppose there's a water gun. So I'll say grab water gun. So my virtual hand in the game will automatically grab the water gun, or switch to ballistic missile, switch to rocket launcher. So automatically we can switch to different objects in the game using voice command. So that can be a feature of voice command. And so basically voice command can be any command or anything you can want. If you are accompanying it with the controller, you must be able to do it with voice command. So exactly, if I'm a solo developer, I won't be able to cover all the use cases. But what I can do is we can create an open source project like in Locomotion. We can prepare an article for voice command, so that if you want to create your custom voice command or implement different features, you can do that by yourself, depending on your requirement.
Awesome. All right. Thank you so much. And now we're going to just do a final wrap up. I mean, I just want to echo what Shivam was just saying, that I really enjoyed getting to work on this project. As mentioned, we were working like US, India, Japan. We were really working all over the world. This is definitely something really cool about VR and like the whole technology that we're doing. I think that really speaks to, right, the future of tech. Our project was able to exemplify that. I'm really thankful to Dylan Fox from XR Access. He got the opportunity for XR Access and Equal Entry to work with the XROS Fellowship, and all three of our presenters today, I'm really impressed with the work that they've done. I would put out like an open call to everyone here. You know, we're working with Unity, we're working with Meta. I really want to make sure that the work that's done gets promoted even more. And one of the whole points of doing this work was there's not a lot of developer guidance on what to do. And we want to take away that excuse for people to not do work on accessibility and virtual reality. And so I think all three of these projects have really shown, you know, within a, you know, I'd say 5 to 6 month time frame, we've built solutions that can improve access for people with disabilities, and we really want people to learn from them and build on them. So as mentioned, they're all open source, and yeah, if you know of anyone that would be of interest to these projects, please share them with them. We will be sharing out links also on the Equal Entry site and on the Alley VR newsletter, and we'll hope to see you at the event in the future. And thank you, Yuvraj, Savio, and Shivam so much for your work.